Hey everyone, welcome to WittCode, where in this video I'm going to be going over everything you need to know about Document.cookie in JavaScript. So before I begin this video, I want to give you a short summary of what a cookie is and also what HTTP is and how cookies and HTTP are related. So cookies are data stored in small text files on your computer that let you store information. Specifically, each cookie is a key value pair along with a number of attributes that dictate when and where that cookie is and can be used. HTTP is a protocol that allows for fetching of resources, such as HTML documents. It was designed for communication between web browsers and web servers. HTTP is also a stateless protocol, meaning that the connection between the browser and server is lost once the transaction ends, and this transaction being retrieving something from the server, such as a web page, posting something to the web server with a post, and so on. But because HTTP is a stateless protocol, when a web server has sent a web page to a browser, the connection is shut down, and the server forgets everything about the user. And so, cookies were invented to solve the problem of how to remember information about a user. So now, when a browser requests a web page from a server, cookies belonging to the page are added to the request. And this way, the server receives necessary data to remember information about users, because remember, HTTP is a stateless protocol. So after the web server has sent the page to the browser, the connection is shut down, and nothing is remembered about the user. So cookies basically solve this. And now JavaScript has an object called document. And it's an object, so let me show you this real quick. We do type of document, we can see it's an object. And what document does is it represents any web page loaded in the browser and is also an entry point to the web page's document object model tree. And it has a property called cookie that lets you read and write cookies associated with the document. So we could do document.cookie. And so in other words, this document.cookie here is a getter and setter for the actual values of the cookie. So whatever we write into document.cookie can be used by the server to identify us as a particular user in an application. So to create a cookie, all we have to do is document.cookie, and then equals, and it's a key value pair, go over more of this in a second, and then username equals WittCode. And now let me just list out document.cookie again. First thing you can see is it got rid of this white space. Basically, each cookie is a key value pair. So you have a key here and then a value. And now if we sent a request to a web server, the key value pair username equals WittCode would be sent to it. So then say the server has some sort of database it can go through, and it'll match the key WittCode and search in the database for any information related to WittCode. Of course, this would usually be some sort of ID or something like that, but just to make things look a bit easier, we're just going to use a username here. So once again, the server could use this information to fetch everything related to our username. And again, this would more likely commonly be an ID or something that the server would look up in a database, but for simplicity, we just assume here that it's a username. But anyway, let's add another cookie. So to do that, all we have to do once again is document.cookie, and then set that equal to another one. This time, let's do pizza equals tasty. And you can see now if we list document.cookie, we have both cookies, and they are separated by semicolons. So this here is a cookie, a key value pair, and this here is also a cookie and a key value pair. And even though we just did document.cookie equals this, you would maybe think it would overwrite username equals WittCode, but that's not true. It just appends it to the object with some underlying magic, essentially. But so far, we have just been looking at the cookies by typing in document.cookie into the browser. But we can get a better look and more information on these cookies in our Chrome DevTools application tab. So that is this tab right here. And if I click on this, let me zoom out for this here. And I'll also adjust this screen. And then scroll up here. And you can see under storage, we have this right here called cookies. And real quick, the application tab is used when a web page deals with cookies or local storage. And you can use this tab to see every cookie that a web page has, what's in your cache or session storage, and things similar to this. But in this video, we're just going to be focusing on the cookies part of this application tab. So within storage, just on the cookies right here. And you can also see it's for each domain. So in this one, we have I'm running this in VS Code, this website right here, and I'm just running this in the background, or just running this using live server. So it gave it the port, and it's essentially a domain at localhost and port 5500. But right off the bat here, you can see the cookies that we created. So when I type in document.cookie again, the cookies we created, username equals WittCode and pizza equals tasty, are in this application tab in our storage and under cookies. Remember, each one of these is a key value pair and a cookie. And we have here the name is pizza, which is the key, and the value is tasty. And then same for WittCode, we have the username, or name is username, or key, and then the value is WittCode. But you can also see that there are other values for a cookie that we can set besides just a name and value. And these are domain, path, expires or max age, size, HttpOnly, secure, SameSite, SameParty, and priority. Some of these are Google Chrome or Chrome DevTools specific. I believe like SameParty and priority are, but I'll be going over those a little bit in this video, but I'll more so be focusing on the universal attributes. But we are going to be going over each one of these properties from left to right and how to set them and alter them, all with just document.cookie. Let me pull this down again a bit. And let's start with domain. So this column here, because I'm going to be, see if I can increase this. Awesome. So I can have this, and then I'm going to clear here. Let's also make this bigger now because we're going to be using that. Trying to get this a good view for you guys. But anyway, yeah, let's start with domain, so this column. And this column has the hosts that are allowed to receive the cookie. So you can already see that we have a domain for the cookies created. And this is because, so this domain here, which is 127.0.0.1, which means localhost, which basically means your own computer. And we didn't specify a domain when we were using document.cookie like this, but that is because if no domain is specified, then it defaults to the host portion of the current domain location. And so of course, because we specified no domain, it's just 127.0.0.1. But what we can do, of course, is just specify a domain using the key domain. So let's update our WittCode cookie so we can use this document.cookie to change the domain in here. And to do that, let's do our username equals WittCode, and then we separate it, remember, with a, what you want to do is you want to separate it with a space and a semicolon. This is just still one cookie, but we're just separating out the attributes essentially. But say we want to change if we want to change the domain, we would just do something like this. Say we want to change it to the domain to be youtube.com. So then let's hit enter, and let's refresh this. And this is actually a little bit of a trick because this is how you update this domain here. But even though we set it to YouTube, it was ignored because the domain must match the domain of the JavaScript code's origin. In other words, if we set cookies to foreign domains, then they will be ignored. Of course, for security reasons, you can't just go setting cookies with a domain on some random website because that just wouldn't really make sense. But so here, example, youtube.com is ignored because it is a foreign domain. And also, because we were using localhost in this example, we don't really have many options for the domain besides localhost, so the default value here is really all we have. However, an important note about domains with cookies is that cookies set on a domain will be available on all subdomains. So for example, if we set the domain equal to, so say we did this, and we had the domain equal to mozilla.org, then that cookie would be available on the subdomain developer.mozilla.org. And it would also be available on another subdomain, say, I don't know, pizza.mozilla.org. And then, so that's just something to keep in mind. Sorry I can't give you a real life example with my domain here right now because I'm using localhost. But something I want to show you as well is that you might see the domain starting with a period occasionally. So let me actually bring up an example of this. So in here, for example, this is just on Google's main page, just on google.com. You can see we have the domain as .google.com. So the leading dot here means that the cookie is valid for subdomains as well. So if we have .google, that means that myblog.google.com would also be okay. So because we have .google, it'd be, if we had another, say, subdomain like myblog.google.com, that would be okay as well. But something you should know is that this is actually outdated. So current HTTP specifications change this rule so that modern browsers do not care about the leading dot. In other words, leading dots in domain names are ignored. And instead, if a domain is specified, subdomains are actually always included. So it doesn't matter if we do, like, say we made a cookie here, and we did like, remember how we do that would be document.cookie equals, let's do username equals WittCode. And then if we wanted to specify the domain, we use the domain key like this. And so we could just do google.com, because if we could do .google.com, but that's outdated and it just does the exact same thing as this. But now let's start talking about the path. So let me go back to my localhost here, and we're going to be talking about this column. And so path is essentially just what the name suggests. It is the path that the cookie is available at. So you can see when we created these, so when we created like these cookies here, WittCode and pizza, if you don't specify the path, then it defaults to the current path of the current document location, which of course for us is just the root, because in this, what I have here, all it is just this index file. It's not linked to anything at all. So that's why we're just accessing it from within here. So for example, if I just create another cookie in here, let's create another one. Let's do soccer equals fun. Refresh this. We get soccer equals fun, and the path is just here. Refresh this again. But now what I can do is I'm going to create a folder and have an anchor tag that goes to a file inside it, and then create a cookie in there, and I'll show you how path impacts the cookie. So I'm going to go into my VS Code here. I'm going to create a folder, call it, or actually I think I already have one right here called my folder. And what I'm going to do is I'm just going to create an anchor tag inside this body here. So A, and we're going to do an href, is going to be -- my folder, and then file and folder. And let's also do some internal styling just to make this bigger. I'm just going to do font size equals 5 EM, which means 5 times the size it would be. And I'll call this link to another page. And now let's go back here. You can see we are actually inside, or we've got this link to another page up here now. Let's click on this. Now, and then here, let's set a cookie. So let's do document.cookie equals, and then we'll have WittCode equals subscribe, like this. And then if we refresh, you can now see that the path is inside my folder, because up here we are no longer in root, we are inside a folder. And you also may have noticed that these other cookies are here as well. Even though the path is the root, they are still available on this web page inside my folder. And this is because if we set a path to just root like this means that the cookie will be accessible to all pages in the domain, which is why they're still accessible even though we're inside my folder. But however, if we set the cookie path to be a specific folder, like we did in here, for example, then it won't be accessible in the parent folders. So now if we go back to just our root like this, you can see that cookie is gone because we don't have access to it because the path for it was inside my folder. But then let's go back to this page, and you can see it's back now, so we can access it again. And now something as well, so we can create a cookie in here, and we can specify the path. So say I do document.cookie, I'm running out of names, coding equals fun, and then let's do a path. Remember, don't forget the semicolon here. And if we set the path equal to dash my folder, you can see it was put in here. Let's refresh this, click on link to another page, and you can see it's in here. So we have coding and fun, and it's available within here, But even though we set the cookie on the home page here, it doesn't mean it'll be available because the path was set to just my folder. And just know we can also, I've just been setting this to folders, or the path to folders at the moment, but we can also set the cookie path to a specific file. So I could do document.cookie equals like this video equals yes, and then I do path equals dash my folder dash file in folder.html, and then, is that how I did it? Yep. And so if we refresh this, of course it's not going to be available here because it's in a child directory, but if we go to the other page, refresh this, we can see now that this is present in here, and the path isn't the folder, but it is the file. So file in folder.html. So we are technically in file in folder.html, but this is available because it's a parent directory. So that's why it's available here. And for example, just once again, and that's why it's not available here because it's a child directory. So just to reiterate, cookies are only accessible to the specified path and any subpaths, but cookies are not accessible to superpaths. But now let's talk about the next column, which is expires and max age, or the max age and expires property of a cookie. So both of these properties determine when the cookie is no longer valid or when the cookie is deleted. And a common question programmers have is the difference between max age and expires. And expires actually was deprecated and replaced with the easier to use max age. And it's easier because for expires, you have to specify a date, while with max age, you just specify the time in seconds until the cookie expires. You may also have noticed how it says session here. So in each of these it says session. And this is the default value if you don't specify an expiration. And session just means when the browser is closed. So if I close this right now, it will delete all these cookies. So actually let me show you this. So I'm going to delete that. And then let's open this up again. Let's go in here. Click on our cookies, and you can see all our cookies are gone. So all that hard work, those are now gone. But anyway, because expires is deprecated, I'm not going to spend too much time on the expires key, but I'll be focusing more on max age. And this is of course set with the max age key. So let me get rid of these. I'm going to type in document.cookie equals username, WittCode, and then next to that, let's do max age and set that equal to just 10, like this. And what this means is, because remember max age is in seconds, this is saying make this cookie and then have it expire in 10 seconds. So basically we can just sit here, let's have this refreshed, and you can see the time it actually expires. I'll go over this more in a sec, but if we keep refreshing, you can see it's gone now because 10 seconds have passed. So once again, let me make this cookie again. You may have noticed, as I said for a second, that even though we specify the time in seconds for when the cookie should be deleted, it is still in a date format. And this format is called GMT string format. And you can get the current time in GMT string format by doing the following. So all we do is create a new date object, and then we use .toGMT string. And you can see this is what we get printed out. And let's compare it to this here. If I can move these over, you can see the similarity here. It's like October 21st, 2021, and the time is 20:43:17. And so you could see that this is 20:43:31, where this is 20:43:17. So that means this should be expired. So if we say we create a cookie like this with max age, let's check it, and it's 20:44:21. Now let's quickly create this, 40:17, 19, 20, 22. So now it's gone. So that's just I guess a way of just showing you what this is. But so that's basically it with max age and expires. But the next key that I want to talk about is size. And we cannot explicitly set this, as this is determined automatically. And what it means is the size of the cookie in bytes. And this basically always corresponds to how many characters are in the name and value combined. So if we just did, let's do an easy one. Let's do hi equals yo, like this. Type it in, we can see the size is 4 because hi is 2 characters, yo is 2 characters, so it's 4. Or say we did hello and then goodbye, and we refresh this, we get 12, and I believe 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's 12. So essentially size, it's a number of bytes, and it usually corresponds to how many characters. So that's just a very easy property to go over, and we can't set it with document.cookie, as I said, but it's just an easy one to go over. But now the next property we're going to be talking about is the HTTP only attribute. And a cookie with HTTP only is inaccessible to JavaScript's document.cookie. And so because of this, we can only set this attribute on a cookie by using a server-side framework or code. In other words, something like Express.js or Happy.js, but this also leads into a good discussion topic. And that is setting cookies using the server side, such as Happy or Express.js, and using document.cookie on the client. So that was something I found confusing at first, but know that there is no such thing as server-side cookies and client-side cookies. There are only cookies, the name-value pairs sent in HTTP headers with requests and responses. In other words, the cookies you set on the server using Express, for example, will show up in the same application tabs as the ones set with document.cookie. So if we were using Express as our backend here, and then we were setting cookies as well on the server, they would show up in here along with the ones we set with document.cookie. So if you want to implement the HTTP only attribute on a cookie you are making, you will not be able to do this with document.cookie. Instead, you should look up how to do it with Express, Happy, or whatever server-side framework you are using. So just to reiterate, the HTTP attribute doesn't let the browser JavaScript access the cookie. But let's move on to the next cookie attribute, which also deals with security, and it's called secure. So you can set the secure attribute on a cookie by just adding the string secure. So say we do document, let's update our hello goodbye, and what we're going to do is just add on the key secure. And now if we refresh this, you can see now we have a little check mark in this box here. So a cookie with the secure attribute is sent to the server only with an encrypted request. In other words, the cookie will only be sent to the server over HTTPS and never with unsecured HTTP. And this is so the cookie can't easily be accessed by a man-in-the-middle attack. And also, insecure sites, meaning sites with HTTP in the URL, can't set cookies with the secure attribute. So if we were in a website that had secure attributes set, if we were at a website that was HTTP, we wouldn't be able to use document.cookie and set the secure attribute like this. But when it comes to localhost, I believe HTTP is allowed because I don't think we're technically using HTTP here or HTTPS, but it is allowed. But that's all secure really means, and that's how you set it with document.cookie. But the next property to go over now is the SameSite attribute. And the SameSite attribute allows you to declare if your cookie should be restricted to a first-party or SameSite context. Let me pull this down here. But before I explain this more, let me go over first-party versus third-party when it comes to cookies. So we know that the cookie is associated with the domain from our domain attribute here. And if the domain of the cookie is the same as the domain as the page you are on, then that cookie is a first-party cookie. So right here, the domain is 127.0.0.1, and that's what we're on here. So this is a first-party cookie. But if the domain of the cookie is different than the domain of the page you are on, then the cookie is a third-party cookie. So let me go to Google again. Let me see if I have one set on here. So application tab, cookies. Let's go. No, so there aren't any here. I think there might be one on Stack Overflow. Just do this just to give a better visual. So it's .stack overflow. So right here, like .scorecard, this is a third-party cookie. And I think scorecard is probably just something that like gets user information, but this is known as a third-party cookie because you can see the domain here is .scorecardsearch.com, but up here we're on stackoverflow.com. But anyway, let me go back to here, And you might have put this together, but this also means that the same cookie can be either first party or third party, depending on which site the user is on at a given time. And cookies may come from a variety of different domains on one page, as you saw in Stack Overflow. And this is possible because while the server hosting a web page sets the first party cookies, it is possible that the web page may contain images or iframes stored on servers and other domains, and it is these that may set third-party cookies. So I don't know if any of you have ever made a website with Amazon affiliate links. I have a website, WittCode.com, that I do have Amazon affiliate links are, and those are all iframes. And so these are most likely going to be holding third-party cookies. So it could be these iframes that are setting third-party cookies on my website. And actually, let me show you that real quick. So if I show you my website here, so it's basically just some code from my things that you can download from some of my videos. But I have ad blockers, so they won't be showing up here, but they should still be in this application tab. And so if you look, you can see I have all these third-party cookies, which are most likely coming from the Amazon affiliate links that I have. And these are also third-party because the domain is nothing like my domain up here. But anyway, that's just to show you this. It's a cool website too. You should check it out. But so when this comes to the reason I'm going over this first-party and third-party cookies is because the SameSite attribute allows you to declare if your cookie should be restricted to a first-party or same-site context. So first-party essentially means the same-site context. And let me show you how to set the same-site attribute real quick, and then I'll go over the different types, and then I'll give you some more examples. But so to set it, we of course just use the way we've been doing with the others. So let's make a cookie called WittCode, or let's just update our one here. Hello equals goodbye. And then in here we will to add SameSite, we just use the key SameSite. And the SameSite value here can take three values. It can take lax, like this, strict like that, or none, like this. And we're going to start off with strict. So the way we do that is we would just set it like this. I'll go over why that didn't work in a second. Sorry, not strict, but secure. Oh, the reason it wasn't doing this is because I was overriding it. I forgot this semicolon here. So let me try that again. Let's refresh it. There we go. So now you can see it says strict. So what I was doing is because I didn't have a semicolon here, it was adding this on to the value. But anyway, let's do this. Also, let me check one more thing. Okay, so it didn't need that secure attribute. I was mixing that up with something else. Anyway, just forget all that. But just so right now, let's just go over the strict property. And we set it with document.cookie using SameSite equals strict. And SameSite equals strict, this means that the cookie is sent only to the same site as the one it originated on. So let me give you an example. I don't have a hosted website I can demonstrate this on. I can use mine, WittCode one for example, but I'll do this with a PowerPoint demonstration. But so the way I'm going to show you, let me actually, if I can use not a pen, laser pointer. So this right here is basically some kind of make-believe website. And in it, we have three things. So we have an H1 tag here. This is the website. It's WittCode's cookie shop. And then we have an image here where this image is actually from a different website. So you can see it says this image is from a different domain. And you can only see it if you have a cookie set. And not only a cookie set, but a cookie set on the domain that you are getting this image from. So this is a website, but this image is like it could be in an iframe or something and is coming from a different website. Then we also have a link here that takes you to the different website. So it takes you to the website that this image is from, that this whole website is embedding into it. So just once more, this image would only display if you have a valid cookie. In other words, if you are on the site that this image is from, it would only display if we had a cookie from that site. So here, we are assuming that we have a cookie on our browser from the website that we are using to embed this image. So this image is only showing up on this website, WittCode's cookie shop. This could be like let's call this like red website or something. If we have a cookie set on red website that allows us to see this image on it, and we are embedding it onto WittCode's cookie shop, then we can see it. So the cookie that we are talking about with the SameSite property, it belongs to the website that this link takes you to and that this image is from. So when we're talking about first party and third party, we're not talking about WittCode's cookie shop. We're talking about the cookie from this website that this image is from and that this link takes you to. And now, if the website we took this image from and the link takes you to had the SameSite strict attribute on it, then this would happen. Let me go to the next slide. This image you can see is broken, and this link also will not work. And this is because with SameSite strict, the cookie is sent only to the same site as the one it originated in. So if you remember, I called this like red website or something in the slide before. This website, if it had cookie set to strict, the image would be broken on a different website, because this WittCode's cookie shop is basically a third-party website, you could say. So once again, this is because with SameSite is strict, the cookie is sent only to the same site as the one it originated in. And if there is an embedded source, such as this image, from a website whose cookie is set to SameSite strict, then the image will not be displayed. Also, if we clicked on the link that takes you to the website where the cookie is set to strict, then you will be denied and receive a forbidden message. On the other hand, though, if we had the SameSite set to none using Document.cookie, so remember that SameSite attribute and we just had it to none, it would look like this. The image would be displayed, the link that takes you to the website would work as well. So setting SameSite to none specifies that cookies are sent on both originating and cross-site requests. And there are of course some potential security risks to cross-site request forgery attacks with this. But I'm not going to go in depth on that. But if SameSite is set to none, then the secure attribute must also be set. That's what I was doing earlier. So if we have SameSite like Document.cookie and then equals username equals WittCode and SameSite equals none, we have to have secure set as well, like we did previously in this video. And if you can remember, the secure attribute makes it so that cookies can only be sent over HTTPS and not HTTP. And now let's talk about the final option for SameSite, which is lax. And lax means that cookies are sent when the user navigates to the cookie's origin site. For example, following a link from an external site. So we went here. If we clicked on the link in this domain, the cookie would be sent with the request to the domain that the link takes us to. So the red website, as I said earlier. However, cookies are not sent on normal cross-site sub-requests, for example, loading images or iframes. And this is why the image would still be broken here. And also lax, so SameSite equals lax, is the default option. So cookies without SameSite set default to lax. So just to reiterate this one more time, because I think this is kind of something to confuse you from. This takes you to a different website, and this is from a different website. This is being embedded from a different website, and to see this, you have to have a cookie set, and to go to this website link, you have to have a cookie set as well. And depending on SameSite, which remember depends on first site or first party cookies and third party cookies, it basically changes whether this content is allowed to be like accessed on another website, embedded in another website, or if you can make requests to that website from a different website. But anyway, let's get back into our console now. And now, of course, I think I only showed you strict, but let's say if we wanted to set this, let me just show you this again. If we wanted to set SameSite to none, we have to have the secure attribute set. So if we did that, we get SameSite none and secure like this. But I think if I tried to override it again and did this, let's run it. We can see we actually got an issue. And there we go, marks as secure in cross-site context. So we can't do that anyway. How do I get rid of this? Close these issues. And then, of course, if we just wanted to set it to lax, which is the default, we just do this, and we can set it to lax. But now the final two properties, or the next one I want to go over, is SameParty. And I believe this is kind of a new attribute and also a Google Chrome one, I believe. But it's basically tied fairly closely to SameSite. And you cannot set it with Document.cookie either, so I'm not going to go too in-depth on this one. But basically, SameParty was made because modern websites are usually served over multiple domains, and many of them are owned by the same organization. And the SameParty attribute provides a mechanism to group domains belonging to the same organization as being same party with each other, and thus changes the privacy boundaries for them. And it's also fairly new, so there isn't too much about it at the moment. So that's all I'm going to really say about that, but the final property I want to talk about now is priority. And so before I go over priority, cookies get deleted when they exceed their per domain cookie capacity. And without priority being set, servers will remove the oldest cookies. However, if we set the priority higher on an older cookie, then the newer cookie with a lower priority would be deleted instead. So this flag essentially prioritizes which cookies will be deleted first. In other words, cookies with a lower priority are deleted first. And the default priority is medium. So you can see I think all of these have medium set, but other options are high and low. And I also believe this is another Chrome exclusive. But now we've gone over all the properties, so let's start talking about how to parse a cookie in Document.cookie. So Document.cookie is a string. Let me increase the size of this now. Like if I do type of Document.cookie, it's not an object, but it's a string. So we can't access properties such as Document.cookie.hello, like this is a key here because we'll get undefined. Because this isn't an object, it's a string. So to retrieve values from Document.cookie, we have to parse the string. And let me show you how you could do that. So first thing we could do is we could just use the Java split method, because each of these are separated by a semicolon. So we just did Document.cookie. If I were just typed it in, .cookie, you can see they're separated by a space and a semicolon. And what document.split does is it returns an array based off what we split. So in the first one we have hi equals yo and hello equals goodbye. And remember there'll be a space here as well. But now what we can do is we can actually use JavaScript's reduce method to create an object of it, which would make things easier. So say I just made a variable called my cookies, and I set that equal to, let's do, what was it? Document.cookies, oh man, I exit out of this. Document.cookie.split. This returns an array, and from this array, let's call the reduce method. And I don't know if you know about this, but essentially we have an accumulator, which means after every loop, this thing is basically updated, and a value, which will be each array member. And then we can do a method. And what we want to do is we're going to do some deconstruction. I'm not sure if you know how to do this stuff, but essentially this will make an array out of what we get. Probably make more sense as I go along. Hold on. And then do val. We split this based off an equal sign. So you can see we have these two here. We want to split these now by their equal sign. So we go through this array, and then we get the new key and new val. New key will be the first thing that's split, because remember this returns an array. So if we work with hi equals yo, new key here will be hi, and new val will be yo, because we're splitting it by this equal sign here. And then we're doing some array deconstruction, which basically means set the first member of the array equal to this, and the second equal to this. And then we can use our accumulator that reduce provides us, and say accumulator of new key equals new val. And then on each iteration of reduce, we have to return the accumulator. So we can do that. And then what we also have to specify in reduce is what we want to be the accumulator, which for us is going to be an object. So now if I save this, if I type in my cookies, now we have an object of each of these, which is, we see we have yo, or hi, and hello. And I also think, yeah, I left the white space in there. So you just have to, play around with this to remove the white space. But essentially, because document.cookie is a string, you can't just access it like an object, you have to parse it. Now, a couple more things to go over is it should be noted that You may have guessed this already, but the only information we can get from document.cookie is a key value pair, not any of the attributes we set. So we can't get any of these here, just the key and value. But the next thing I want to talk about is the method EncodeURIComponent. So EncodeURIComponent. And I want to specifically talk about this method's relation to cookies. So EncodeURIComponent is a function that encodes special characters. And specifically, it encodes ASCII values to URL encode values. For example, white space in a URL is encoded as %20. So if I did this, you could see what were returned as %20. And that's why in the URL you might sometimes see a lot of these % signs, because it's basically encoding dangerous or, I guess, annoying characters or ASCII values. And so what I want to mention about this is you call this EncodeURIComponent on strings. But the relation of this EncodeURIComponent to document.cookie is that it will ensure that the string does not contain any commas, semicolon, or white space, which are disallowed in cookie values and can cause some issues when the cookie is being read by the server. So it's recommended by Mozilla or whatever that you should always use this on your cookie values to just for safety, essentially, because it could cause some issues when the cookie is being read by the server. So in other words, cookies are passed to the server as an HTTP header. So we have seen, key 1 equals value 1, key 2 equals value 2, just like throughout this whole series. And obviously, value 1 and value 2 cannot contain a semicolon or other problematic characters, as this would mess up the parsing of the cookie, because they were separated by a white space and a semicolon. And so the way around this is to choose an encoding and use it both on the browser and on the server, so that, of course, there aren't any issues there, but it gets rid of some issues that could happen if you allow these sort of ASCII characters into your cookie string. And then just one final note is you might have heard of cookie flags. And examples you might see them online are like --secure, which tells the browser that the cookie should only be included in HTTPS. And you might also see __host, which says the cookie must not have a domain attribute. It will only be sent to the host which set it. But I'm not going over these because these cookie flags have become deprecated since actually June 2nd, 2016. So don't worry about those. But this was my video on document.cookie in JavaScript. If you have any questions, reach out. I'll try and get back to you. I also think I'm going to start uploading some of my videos more so as like a script or like in a blog format to that website that I'm building. It's a little buggy at the moment. I kind of just have it up just because it was something fun that I wanted to do. And but I think I might start doing something like that, so be on the lookout for that. But besides that, thank you for watching, and I hope to see you in the next video.